7th grade, and welcome to Lesson 5-1 on comparing and ordering rational numbers. In tonight's lesson, we have two objectives. First, you will be able to find the least common multiple, and secondly, you will be able to compare fractions. All right, and we're going to skip the warm-up and go straight to the first part of today's lesson, which talks about multiples. When we're talking about multiples, this is much different than finding factors of a number. In fact, it's the opposite. When we find factors, we find out what numbers make up a product. When we do multiples, it's that product of that number and any other non-zero number. So really, you're counting by that multiple. So for example, multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32. And again, you could think of this as 4 times 1, 4 times 2, 4 times 3, and so on. All right, or again, you're adding 4 each time. Now we could do the same things with 6. It'd be 6, 12, 18, 6 times 4 is 24, 30, and so on. All right, so we can do multiples. Now when we talk about least common multiples, we look for common multiples of 2 or more numbers. So I could find multiples of both, or common multiples. Both of them have 12 in common. They both have 24 in common, and so on. Now, when we talk about the least common multiple, it's a number that is the smallest that they both have in common. So in this case, our least common multiple would be 12 when we do the multiples of both 4 and 6. So here we have an example. Today, the school's baseball and soccer teams had games. The baseball team plays every 7 days. The soccer team plays every 3 days. When will the teams have games on the same day again? Well, we're going to use the least common multiples idea to do this. We know we are talking about the baseball team, and we are talking about the soccer team. Well, baseball plays every 7 days, so you'd have multiples of 7 here. All right, and here we're going to have multiples of 3. So we want to find the least common multiple they both have in common. So for baseball, we'd go 7, 14, 21, 28, 7 times 5 is 35, 7 times 6 is 42, and so on. We could do the same for soccer. Well, we're going by threes. 3, 6, 9, 12, 15, 18, 21, 24, and so on. Well, if you take a look, we're looking for the least common multiple, and I find that they both have 21. So that means they're both playing again on the 21st day. That would be your answer. We found the least common multiple to find when they both would play again. So here I have, find the LCM of the following numbers. I would like you to do A, B, and C. And when you're all done, come back and check your answer to see if you have them right. So go ahead and pause me now. All right, let's go ahead and check A. Well, for 3 and 4, we'd count by 3s. And we'd count by 4s. And right away, I notice they have the multiple of 12 in common. So my LCM here is 12. For B, we have 4, 8, 12, 16, 20, 24, 28. 5s, we have 5, 10, 15, 20, 25. And again, I noticed right away they have 20 in common. So there we go. All right. Now, you might have noticed for these two first ones, you did 3 times 4, and you would have had 12. 4 times 5 is 20. Now, I'm going to tell you this. It doesn't always work that way. Just because you can multiply the products together or the numbers together, it doesn't always give you the LCM. All right, so you want to watch for that. And then 3, 4, and 5 we have to do. Well, we have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39. And let's see if I find any here. I might have to keep going. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60. And I have to do 5s then. 5, 10, 15, 20, 25, 30. And I keep on going. 35, 40, 45, 50, 55, 60. Well, if I take a look right now, well, I see that 3 and 4 have 12 in common, but 5 doesn't. Let's see. Oh, 4 and 5 have 20 in common, but 3 doesn't. And I keep going down my list. And it looks like I have not gone far enough yet. So I'm going to add on more to these 3s. So 39, 42, 45, 48, 51, 54, 57, 60. Whew. Took some time and a lot of writing, but I think I found it. I take a look and I see, well, there's a 60, a 60, and a 60. All right, when we find the LCM of 3 numbers, that number has to be a multiple of all 3. So here our answer is 60. All right, now that is one way you can do the prime factorization, or find the LCM, I should say. The other way you can do it is using prime factorization. And that, again, just means to do the factor trees. So find the prime factors, and then from there, you're going to take the greatest power of each factor. So again, I can do 16. I can do 2 times 8, 2 times 4, and then 2 times 2. And I could do 36. Well, that could be 4 times 9, and I get 2 times 2 and 3 times 3. There we go. So I did the first piece. I did the prime factorization. Now for the second one, it says use the greatest power of each factor. So when we found the greatest common factor, we had to find the groups that went together, and we multiplied those. Here we're doing the opposite. All right, I noticed that there are 4 2s over here and only 2 over here. I want to take the greatest amount. So I'm going to take 2 times 2 times 2 times 2, because there are 4 2s over here and only 2 over there. And then I notice there's also this group of 3. Well, this one has 2. Over here in the 16, there are none. So this is the greatest amount. We have 2 3s that are the greatest. There's 0 3s over here, but 2 over there. So then I multiply this together. 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 times 3 is 48, and then 48 times 3 is 144. So the GCM, or LCM, the least common multiple, is 144. And again, this would have taken a long time to write out. So using the prime factorization helps. We're going to go ahead and do A together again, and then I'm going to leave you to do B and C. So again, we start with finding the prime factors. 6 can be broken down into 2 times 3. 16 is broken down into, well, 4 times 4, and each 4 is broken down into 2 groups of 2. There we go. And then we take the greater factors. Well, there's 2's on both sides, but the 16 has 4 of them. So I'm going to times by 4 2's, and then, oh, there's an extra group of 3 that's multiplied in. So I multiply. 2 times 2 is 4, 8, 16. 16 times 3 is 48. The LCM is 48. I would like you to do B and C. And go ahead, go through them. Use prime factorization. Don't make a list of multiples. And when you're all done, come back and check your answer. So go ahead and do that now. All right, let's check B then. So we have to first break up 9 and 15. Well, 9 is 3 times 3. 15 is 3 times 5. So I take a look. 9 has a greater factor of 3, or the more of them. There's 2 over there, 2 3's, and then there's this 5 here. So 3 times 3 is 9, times 5 is 45. The LCM is 45. Now I do the same idea here for C. Break down 12 into 3 times 4, but that is 2 and 2. 15 is 3 and 5, and 18, Well, that can be broken into 3 and 6, and then that into 2 and 3. So I take a look, I see 2s, 3s, and 5s. So if I take a look, I have 2 2s here and only 1 here. I take the greater number, so I do 2 times 2. Now I'm looking at 3s. There's 1, and then here there's 2. So I'm doing it times 2. And then, oh, there's just 1 5, so that automatically gets multiplied in. Then I multiply. 2 times 2 is 4, times 3 is 12, 12 times 3 is 36, and then times 5 is 180. That would be your answer. So that's the first piece of your lesson. And of course, you can use variables as well to do the same idea. You could break down these numbers. I have 5a to the 4th, and then 15a. It works the same way. 5, if I factored out 5, well, that's a prime factor itself. But 15, you could do 3 and 5. So here, I take a look at this. Well, there's a 3, and there is also, on both of them, they multiply by 5. So you just times it by 5. Then you do the same with the variables. Well, I have 1a here, and then I have a to the 4th here. Well, the greater one is a to the 4th. So I multiply it. 3 times 5 is 15, and a to the 4th. That would be your answer. All right, so now we're on to the next part where we can compare fractions. And one way you can do that is by using a number line. As with integers, anything that's positive, any positive fractions are to the right of 0, and any negatives are to the left of 0. So if I put 0 here, again, and you can use number lines. This one's pretty easy because it's 7/8 and 3/8. Well, if I do 1, 2, 3, 4, 5, 6, 7, 8, this would be 8/8 or 1. I could graph them. Well, 3/8 would be there, and then 7/8 would be right here. Again, the number closer to 0 here is the smallest, and the one going to the right, it just keeps getting bigger. So, what one's bigger? Well, that would be 7/8. All right, and again, you could do that here as well. This time, though, we have negatives, and we could take a look and say, well, 4, 5, 6. There we go. We could do negative 1/3. Well, I know negative 1/3, that's split into 3 groups. So 1, 2, 3. This would be negative 1/3. Well, negative 1/6, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. There we go. So if we take a look, negative 1/6 is actually greater than negative 1/3. So again, you could do it that way. That's one way you can compare. Another way, and the way I like, is using the least common denominator. What you end up doing is finding a multiple for both fractions, and then you find equivalent fractions and compare them that way. So for 1/2 and 3/5, take a look at the denominator. I have a 2 and a 5. Well, I need a multiple of both, and I could go ahead and multiply them. 2 times 5 is 10. So I could switch 1/2 and find an equivalent fraction to 10, and do the same with 3/5. Well, to do this, well, 2 times 5 gives me 10, so I have to multiply the top by 5 to find the equivalent, and I get 5/10. Here I times by 2. 5 times 2 gives me 10, so 3 times 2 is 6. The greater fraction here, we have 5/10 or 6/10. Well, that would be 3/5, because 6/10 is a tenth more. So here, the softball team won 6/7 of its games, and the hockey team won 7/9 of its games. Which team won the greater fraction of its games? I want you to go ahead and do this one. Go ahead and find a common denominator, write equivalent fractions, and then compare them. So go ahead and pause me now. All right, let's check out the softball team. We know the softball won 6/7, and the hockey team won 7/9. So I need a common multiple of both. And let's see here. I know that, well, 9 times 7 is 63. That would work. Now again, you might have done a different number, and that's okay too. It's just whatever you find. So here, 9 times 7 gives me 63, so 7 times 7 is 49. Here I times 7 by 9 to get 63, so 6 times 9 is 54. If I take a look, they won 54 out of 63, and the hockey team only won 49. So this one is a bigger one. So which team won more? The softball team. All right, and you could do the same things with positive or negative numbers. I think I'm going to have you do A, but cross out B. So go ahead and do A really quick and then come back and check your answer. So go ahead, pause me now. All right, let's check A. We have 6/7 and 4/5. Well, I know 35 is a multiple of both. So I take a look. Well, 7 times 5 gives me 35, so I multiply the top by it and get 30/35. Here, I times the bottom one by 7, and I get 28/35. So which one's bigger? Well, that would be 6/7 is greater than 4/5. All right, and again, now this moves on to the next piece. Here they want us to order 3/7, 1/4, and 2/3 from least to greatest. Again, you could use a number line, or you could use that way we just found out, find a common denominator. And that's how I would do it, because then you're not struggling trying to figure out where each one goes. So I know I have 3/7, 1/4, and 2/3. This time, I need a multiple of 3, 4, and 7. So, again, I could do factor trees, or I could just multiply those numbers together and get it. So 7 times 4 is 28, times 3 is 84. So I know 84 is a multiple of 3, 4, and 7. So then I have to decide, well, 7 times what gives me 84? And again, I could do some work on the side, see how many times 7 goes into it, and I get 12. So I times this one by 12. 3 times 12 is 36. Now this one, 4 times something gives me 84. Well, that would be 21. So I times the numerator by 21 and get 21/84. Then this one, again, I'm going to do some work. 84, how many times 3 goes into it? Well, 3 goes into 8 twice. So that one's times 28. So 2 times 28 is 56. So we can take a look now by looking at the numerators and seeing the smallest to the greatest. Here the smallest is 21/84, which is 1/4. Then it is 3/7, and then it is 2/3. That is ordered from least to greatest. And that's your lesson for tonight. Tonight we use the least common multiple to find multiples of numbers, and we also compared and ordered numbers when using the LCM. So have a great night. See you tomorrow.